Hi, this is Mrs. Nearing, and in this video we're going to talk about significant figures, and then I'm also going to go through the answers to the Kahoot so you can um, figure out what you missed if you missed some problems there. Okay, so, and you can always email me to follow up or stop by the, afternoon office hours to ask questions. So, first let's talk about the idea behind Sig Figs. So, scientific measurements are reported so that every digit is certain except the last, which is estimated. So, the way we write numbers down matters. If we are reporting out our data, the way we write those numbers down, people are going to interpret that in a certain way. And the way that people interpret it is that the last digit that you report is the one that you're uncertain about. So that's the one that would be some variation in it. So for example, if somebody says that your sample weighs 5.213 grams, that means we know for sure the 5.21 part of it, but the 3 could be a little off. Maybe if we were to weigh it again, we would find it was 5.211 grams, or maybe it's actually 5.215 grams. That last digit is the one that's uncertain. So writing it down this way tells us something about how, confident we are in our value, how certain we are about it. Here's some examples over here, which we might run into something like this in a lab situation. Let's say you were to use, a graduated cylinder here to, measure out some water, and you had 52 milliliters of water. Here's a couple different ways in which you might record that: 52, 52.0, 52.00. These three ways of writing it all send very different messages. If I write 52, remember the last digit we write is the one we're uncertain about. So if I say it's 52 mils, that means maybe it's 51, maybe it's 53, maybe it's 54. Like, we're uncertain about the ones place. There could be some variation in there. If I write 52.0, that means we're certain about the 5 and the 2, but our uncertainty is in the tenths place. So maybe it's 52.0, but maybe it's, 52.1 or 52.3. Okay, so we're more confident in this measurement, so we have a greater degree of certainty. If it's 52.00, this tells us the greatest degree of certainty, the greatest number of significant figures there. This one's going to vary in the hundredths place. So the 52 and 0 we're confident about, but maybe it's actually 52.01 or 52.02. So that's the importance behind the significant figures. It's when you're reporting your values to someone else, so they can know something about how you measured it and how accurate those numbers are. And so we want to make sure we get in the habit of doing this early on and reporting our values accurately. So there's some rules behind significant figures. Notice that for non-zero digits, it's easy. All non-zero digits are significant. That one's easy. All the other rules are about zeros. So zeros are where it gets complicated. If there's zeros between two non-zero numbers, those are significant, like these examples. Leading zeros are not significant. So if they're over to the left, and if they're the very first thing you see, those leading zeros are non-significant. Trailing zeros are significant if there is a decimal. So all these are examples of, some trailing zeros that are significant. If you have a trailing zero without a decimal, they will be not significant. So in this value up here, if you say, I have, 1,200 rocks, then that only has 2 sig figs in it. It's only the 1 and the 2 that are significant. These 2 zeros are insignificant. So if I were to say I have 1,200 rocks, I probably mean, like, I don't know exactly how many rocks I have. Maybe it's 1,100, maybe it's 1,300. It's more of a rough estimate there. So this number only has 2 sig figs. Okay, so now let's go through, one more, exact number. So we sometimes will run into things that are exact numbers that tend to be, definitions. So for example, the fact that 100 centimeters is 1 meter, that definition, we think of these values, the 100 and the 1, as having an infinite number of sig figs to them. Or if you say that you have 3 atoms, like we have exactly 3 atoms. Like where you might see this is in a chemical formula, like the CO2. This 2 there has an infinite number of sig figs in it. That's part of the definition. There are exactly 2 oxygens for every 1 carbon atom. Another place you might see these exact numbers show up is when we talk about molar masses. So if we say that 1 mole of carbon is 12.01 grams, this value over here, the 1, this is what we call an exact number. That's part of a definition. So that 1 right here has an infinite number of sig figs. This right here is a mass measurement. So the way I wrote it here, this has 4 sig figs to it. But it's this piece of it, the 1 mole of carbon, that's part of your definition. That has an infinite number of sig figs. So this is one that can confuse people, so we can, as they come up, we can ask questions about it. So now let's take a look at some things. So how many sig figs are in the value 0.04050? So we know that, I'm going to start underlining things that are significant. We know that non-zero values are significant, so the 4 and the 5 count. Zeros between two non-zeros are significant, so this middle 0 counts. Leading zeros are not significant, so these ones are not significant. Trailing zeros are significant when there's a decimal point. So it looks like this number has 4 sig figs in it. So this is the answer right there. All right, how about this one? We've got the measurement 20 degrees Celsius. So again, I'll underline the ones that are significant. So we know all non-zero digits are significant, so 2 is significant. We don't have any interior zeros or leading ones. We do have some trailing zeros, and we have a decimal. So when we have trailing zeros where there's a decimal, those are going to be significant. So this one has 3 sig figs in it. So the answer to this one is 3. Okay, this one. A beaker contains 150 milliliters of water. How many sig figs are in this measurement? So again, all your non-zero digits are significant. So the 1 and the 5 are significant. And here we have a trailing 0, but there is no decimal. So with the trailing zeros, if there is no decimal, they are not significant. So this value is not significant. So this number only has 2 sig figs in it. And we'll notice that a beaker is not an accurate measuring device. So the beaker won't have very many gradations on it. So if you're trying to measure out water using a beaker, maybe it's 150 mils, could be 160, could be 140. It's not going to be super precise there. So now let's look at sig figs and calculations. There's 2 main sets of rules. There's rules for multiplying or dividing, and then there are rules for adding or subtracting. I'd say in general, people tend to make more mistakes with the adding, subtracting. This is the one you want to be more careful with. When you're multiplying, dividing, you just look at the number of sig figs in all of your values, and the sig figs in your answer should match the value with the fewest sig figs. So in this example, we got 4 sig figs, 5 sig figs, 2 sig figs. So my answer should be rounded to 2 sig figs. In the second one, I've got 5 sig figs divided by 3 sig figs. My answer is going to round to 3 sig figs. So let's look at an example of that. So here is this right here. So we're going to plug that in your calculator. 9.86 divided by 12.56. And I forgot to have a calculator next to me. So I don't, let's see. So let's just look at the number of sig figs though. This one right here has 3 sig figs in it. This one right here has 4 sig figs. So your answer should have 3 sig figs in that. So I think it was something like, I don't know, 0.731. I'm just making something up. So your answer should have 3 sig figs in it. Okay. Let's take a look at another one. This is a subtraction one. So 78.59 minus 77.9. This is what we will often run into this looking at a change in mass or maybe a change in temperature. We'll actually see a lot of subtraction applications in class. And there's a hint here when you're doing addition or subtraction. It might help to kind of write them out this way as shown below. So let's write this out. So 78.57 minus 77.9. And the rule is that the result carries the same number of decimal places. So this one has 2 decimal places. This one is only out to the 1 decimal place. So the answer will only be carried out to 1 decimal place. So if you plug this in your calculator, you get 0.63. Okay. But the way that you would write this down would just be 0.6. Let's write this out. The answer is 0.63, but the way you would report it is just 0.6 because you're only going to report it out to one decimal place, if that makes sense. And notice how I took a number that had 4 sig figs and I subtracted a number that had 3 sig figs, and the result is a value that only has 1 sig fig. And this is something I keep an eye out for in addition subtraction. Remember I said this is the one that people most commonly make mistakes in, and it's because the number of sig figs can change throughout that adding or subtracting process. So just make sure you're really careful with that. It's all about the number of decimal places. Okay, so the rule here is that your answer can only go the 10th place because 77.9 only goes the 10th place. And that's the rule with adding, subtracting. It's different than the rule for dividing. So just keep in mind, it's 2 different sets of rules there. And then this one, we've got both things happening. We've got an adding, subtracting step, and we have a multiply and dividing step. So first we're going to do the adding, subtracting. And what I really recommend that you do is that you write down your answer when you do this subtraction step, because you want to think about how many sig figs are in that value. So this here is going to be a 2, and this is a 2. So these both go to the, 1 spot past the decimal. So my answer is only going to go 1 spot past my decimal. So notice how this value only has 2 sig figs in it. And then to find my final answer, I'm going to take 2.2 divided by 1.264. So this number has 2 sig figs. This number has 4 sig figs. When I do this next step with my dividing, the rule with multiplying and dividing is that my answer should have the same number of sig figs as the value with the fewest sig figs. So my answer is going to have 2 sig figs in it. So I'm going to round it to 2 sig figs. So those are some examples of how we use sig figs. I'm sorry I don't have my calculator on me to test this one out here. Let's look at one more here, this one with egg carton. So a carton contains 12 eggs. How many significant figures are in the value 12? This is an example of an exact value. It has an infinite number of sig figs. There are exactly 12 eggs in that carton. There's not 12 and a half eggs. There's not maybe 11 or maybe 13. There's definitely exactly 12 eggs. So this is an example of where you might have an exact value, like we mentioned earlier. Okay, so hopefully this helps. Please let me know if you have follow-up questions. I'm happy to either help you out in tutorial and make another video going over a concept if I went over something too quickly or we want more examples. All right, thanks.